Artificial intelligence is a transformative force in society, revolutionizing industries, increasing efficiency, and reshaping the way we interact with technology. Generative AI can process vast amounts of data, facilitating quick and precise analysis of concepts, and can be integrated into practical architectural use. This efficiency has contributed to less resource consumption and decreased time typically required for projects, supporting sustainable material use. However, while AI can bring inspiration for new projects and make the process of development more efficient, this technological advancement has also raised ethical and moral concerns that demand careful consideration about how AI could and should be applied. Although AI cannot replace the core of architecture in which human interaction, intelligence, and experience lie, AI has the power to be used as a tool to revolutionize the design workflow for the discipline of architecture. Artificial intelligence refers to computer systems that mimic the human thought process and create new works based on a set of input data. They contain algorithms, which are sets of steps that a computer follows. What creates the distinction between a program with and without artificial intelligence is if the program has a sense of perception, cognition, and goal-seeking behavior. According to Roger Clark, a professor from the Australian National University, there is a level of consciousness computers must have for them to be considered intelligent, one characteristic of which is machine learning, the ability of a program to learn from events and change over time due to sets of rules. In addition to these abilities, AI that generates its own iterations using patterns gained from machine learning are called generative adversarial networks. All generative AI technologies rely on datasets fed to them by developers, so that the program can make patterns and inferences from that information, and finally create an output based off of that information.
The late 1980s and early 1990s marked a pivotal period in architecture with the rise of computer technologies, catalyzing a shift toward digital tools for designing intricate structures. These tools swiftly became a staple among architects, not solely for the design phase, but also for producing drawings that streamlined the creation of efficient forms and facilitated construction information. Among these advancements, AI stands as a transformative tool, significantly enhancing the design and representation processes. AI in architecture operates through computer programs engineered to emulate human cognition, adept at tackling complex problems and dynamically responding to stimuli. A closely intertwined facet is machine learning, enabling AI to discern patterns and autonomously improve cognitive abilities without human intervention. Machine learning permeates various computer platforms like Rhino and AutoCAD, harnessing AI for generating renders, algorithms, and calculations. According to Stanislas Chailloux in his book titled AI and Architecture, a predominant array of AI tools in architecture can be found integrated into existing software suites, functioning as add-ons to parametric extensions within programs such as McNeil Rhino 3D and Autodesk Revit. The utilization of AI presents a pivotal impact on time efficiency and sustainability within architecture. One of its paramount contributions lies in minimizing human error, a factor that significantly influences production timelines. Plans crafted with minimal human error mitigate wastage of resources, be it time, labor, or materials. Moreover, AI drastically reduces the time invested in a project. When AI swiftly generates plans, sections, or iterations within seconds, it streamlines the representation process, thereby allocating more time towards the creative aspects of design and production, and simply better architecture.
Artificial intelligence has and will revolutionize the design process through software plugins and the creation of iterative drawings. Instead of completely relying on AI as a generative tool that fabricates a building from the drafting stages to the completed stages, it can be used as a source of inspiration for initial development. Authors such as Jenny E. Sabin and several architects from her private practice firm detail how AI already exists in programs such as Rhinoceros, Grasshopper, and the plugin Kangaroo in the form of auto-populate structural analysis, where polygon grid structures are generated using parametric computational tools. When used as a tool in conjunction with other software programs, artificial intelligence can serve to be a practical resource that both expands the capabilities of design and optimizes the time taken to reach a refined result. Author Lev Manovich echoes a similar view in support of this application, that AI can be best used as a supplementary tool for the process of creation. He further observes that moving forward, because society assumes that creativity is the driver of the economy, the demand for what AI can do will start to include a more complex skill range. One possibility of this can be seen in the GAN that Stanislas Chilot and his colleagues developed in 2021. The program, which remains unnamed, consists of two major interdependent components, a generator and a discriminator. The generator consists of all the input data, a large selection of existing floor plans. The discriminator classifies the floor plans into 6 metrics or measurements: footprint, program, orientation, thickness and texture, connectivity, and circulation. The discriminator also communicates back to the generator whether the input satisfies the criteria set by the 6 metrics and the developers, and the generator listens to this and adjusts its inputs accordingly. The overall result is a program that produces floor plans and fine-tunes itself with the instruction by developers and the algorithms they set in place. Whether AI is used as an aid in efficiency when modeling designs, or it is used as a complementary set of eyes when reviewing in-process designs, its use in conjunction with other architectural techniques and technologies allow for new and alternative architectural workflows. Although AI has a future of limitless potential with how it is used in architecture, several intellects have called into question the morals surrounding creative boundaries and intellectual ownership. Through the process of machine learning, generative adversarial networks use thousands of creative works to aid in pattern recognition. The use of knowledge and resources from multiple parties like designers, programmers, and algorithms creates a gray area for copyright legislation, as determining who the sole author of an AI-generated work is near impossible. Additionally, AI's dependence on data has been challenged by intellectuals for its inability to exercise its own judgment. Author Neil Leach further challenges this apprehension of machine learning's lack of judgment and notes that we must be cautious of projecting human attributes onto AI and vice versa, due to their dissimilar natures and what defines their respective intelligence. Sophia Crespo and Felician McCormick hold a similar caution in how we understand AI as conscious processors and tools as objective as any other industry-standard computer softwares. Contrary to the misleading image of AI being intelligent like a human, AI is defined by the data it's fed and the instructions given to it by developers. AI, rather than a human substitute, helps serve as a backboard of inspiration, a tool that helps decontextualize its inputs to expand our imagination of the mundane and create art at scales and complexities that would be unfeasible otherwise, challenging the way we think of disciplinary knowledge in architecture. Just as any other tool is used as a resource to help render and improve a final, polished product, AI is a tool that has both extreme potential, yet considerable weakness that ultimately depends on the way that the user interacts with it and the way developers program it.